Okay, if f of x equals x minus 4 square roots of x, where is the graph concave up and concave down? So similar to what your homework asked last night, which means you need first derivative to second derivative. Did you really lose your notes already?
My every class folder's at home.
And you think, just real quick, you think we're bad? Just wait till you get next year, so we're complaining about trade, which is a cakewalk.
They're having Dunkin' Donut meetings.
Yeah, because they're scared about trade.
They are.
True.
It is true.
No, you guys aren't bad. You don't complain. You just get off topic.
No,
Like, it's one thing you're-
get so off
We complain out of class.
I complain. I know I
We just
complain.
complain
I
out of
don't really
class.
care.
Okay, so derivative of x is derivative of 4 square roots of x becomes 4 1/2 x to the negative 1/2, so it reduces to negative 2x to the negative 1/2. So you have 1 minus 2 x to the negative 1/2. I want to drop your x to the 1/2 down right now. I know that I need to take the second derivative. I know that because I know I need to know concavity. So it's much easier to take the derivative when the x is up top as a negative than it is to take it when it's in the bottom. So I'm just immediately going to go to my second derivative. Derivative of 1 is, so now you have negative 1/2 times negative 2. Negative 1/2 take away another 1 becomes negative. Yep. So now I would start to simplify and get rid of my negative exponents. A negative times a negative here became a positive. 2 times 1/2 became 1. So you got 1 over x to the 3/2.
That is 3 square root, or the cube root of x squared, right?
No, it is the square root of x cubed.
Oh, that's like what?
Yeah, whatever the bottom number is the outside and the top number is the inside.
Just always think with those.
Well,
what
I
happens.
always go
we have time to correct. Okay. Set your denominator equal to 0. There's nothing in the numerator to set equal to 0. Therefore, the numerator cannot give me any critical points. The numerator will give you the critical points when the derivative was equal to 0. The denominator gives you the critical points when it does not exist. Because we know that a denominator cannot be equal to 0. So really what you're doing is you're saying f prime of x equals 0, or f double prime of x does not exist. When does it not exist? It doesn't exist when x to the 3/2 equals 0. The second derivative will never equal 0 on this on any domain because there's nowhere for it to equal 0 up top. So this will occur at x equals 0. So that means the second derivative doesn't exist at x equals 0. We have a vertical asymptote then at x equals 0 on the second derivative graph. What happens to the left and to the right of 0? Second.
Wouldn't negative be just like imaginary?
Yeah, so make it imaginary if actually. Yeah. Not since all it's plus.
Always bottom.
So again, what's that tell you about the domain of this function? Yeah, it doesn't exist over here. Doesn't that make sense with the original function? So if this is always positive, then the original graph is always concave up. What?
Just like on Maryland? Oh, God.
This
You might want to cut a couple of seconds out of that video.
Okay, f of x is always concave up. Does f of x contain any points of inflection?
I don't think so.
We don't have any other critical points.
Because it only
How would
increases.
you find
It doesn't, go to concave down.
You cannot have a POI if it does not change concavity. So even though there is critical points, a critical point on the second derivative does not automatically infer a point of inflection. If you want to say this without giving an interval, then you have to say f of x is always concave up on its domain. And I would make sure I have the domain written. It is also fair to just say concave up and give an interval.
So just give us
Hmm?
Just give us an as an interval.
Yeah, so like you don't have to put the words unless they ask you for an answer in terms of words. Yes. Okay. That's the same example. You don't have that one, do you?
That's what we just did.
Yeah, that's why it said it's weird. Did it ask you for all those other parts on your paper?
Yeah.
No. Okay. Let's do this part. Why did I do it the way I have it on my notes? That's so weird. I probably meant to delete this slide. Okay. So we need our first derivative to do the increase and decrease and mins and maxes. So I'm going to take the 1 minus 2x to the negative 1/2. And set this equal to 0. You could imagine this as 1 minus 2 over x with a square root. These are the problems, though. I do like a common denominator, but you don't have to. So it's kind of like the square root of x minus 2 all over the square root of x. That makes it that you don't miss those critical points. So do you get those critical points? So we want to put them on our number line. We already know from the previous slide the domain is x greater than or equal to 0. Therefore, I don't really care about what's happening to the left of 0. I do care about what's happening to the left and right of 4. So I could plug in 1. Remember, when we do our number lines, we are always plugging into our derivatives. So you plug 1 into your derivative. So square root of 1 is 1 minus 2 is negative 1, or negative. Bottom is always going to be, so negative 5 positive is a. Put in something bigger than 4, because you can pick any number you want. So if you pick 5, great, but like in my head, I'm picking 9. Because 9's a perfect square. So like 9's easier for me to go, okay, square root of 9 is 3, 3 minus 2 is 1, 1 is positive. You do 49. Okay, so anything greater than 4 will be positive. So what that means is this original graph is decreasing. Then increasing. So a function that goes from decreasing to increasing has a, yep. So that means this graph is decreasing from 0 to 4, increasing from 4 to infinity, and has a relative min at x equals 4. And in order to find out what your y value is, you plug it back into the original. So that's like f of 4, which would be 4 minus 4 square roots of 4. Or negative 4. Good? So again, very similar to the one that we had in our homework. X to the 1/3, x plus 4. So find your first derivative. Here's the thing. You can do one of two things to find your first derivative. You can do product rule, or you can distribute to start. So by distributing, you get x to the 4/3 plus 4x to the 1/3. I don't know, somehow I don't like doing the product rule. Not that you can't. I just think if you distribute now, it's easier. Just don't make the mistake. When you subtract 1 from 1/3, it's negative 2/3. It's not as nice as the halves. It's not negative 1/3. So again, when I see something like that, I'm thinking, let's make a common denominator. So over here, I'm going to put that over x to the 2/3, which means I'm multiplying this by x to the 2/3. And when you add 2/3 and 1/3, it becomes a nice x. So finding my critical points means I need x plus 1 to equal 0. And I need x to the 2/3 to equal 0. So I get x equals negative 1 here.
Yeah.
So it was originally x to the 1/3. So I wanted a common denominator. So this one has a base of 2/3. So I multiplied by x to the 2/3 on top and bottom. But when you multiply like bases, you add their exponents. So 1/3 plus 2/3 was x. Yes. Put them on your number line. Find the values around them. So if you plug in 1, up here, and anywhere really, 1 plus 1 is 2, x 1 to the 2/3 is 1, so this is all positive, that's positive. Anything greater than 0 will be positive. So again, my derivative looks like this. That's what I'm plugging into right now. Okay, plugging in -1/2. So -1/2 plus 1 is still going to be positive. Any value squared is going to be plug in -2. -2 plus 1 is going to be anything negative squared becomes, so negative over a positive is a. This is the first time we've had a case where it went positive, positive. So what does that tell you about the critical point of 0? It's, don't even think that hard. Just think more like it is not an extrema. Because what happens is it doesn't change signs. It's only an extrema if the derivative changes signs. So that's like the case where you have like the little hill that changes hills. Like the flip like that. So it doesn't, well no, it's not, it's just not an extrema. So it goes from like, this is decreasing. So this is increasing. And then it just is increasing again.
So would the 0 be like, does it go from increasing to not old back to increasing? Like is that why it came out as a point? So it doesn't go down, it doesn't go up at 0, it's just this one.
And if it would help, we can put it in a calculator. You can look at the graph if you want. So look at the graph of the original. So if you want to see what's happening at 0, look at this graph. Use your calculator, see what's happening so you understand what the derivative means. It's okay. Put in x to the 1/3 times quantity x plus 4. So I mean, like if you want to make sense of what the derivative is saying and what we're saying, look at it.
I'll do
Do it.
it.
It should go down. Are we not decreasing till -1?
Oh, here it has a break.
Is it? Am I wrong?
It's like out there.
It's not a break. It's a vertical tangent.
Within the original?
Yeah.
It just didn't show my graph.
It looks like what we're saying. Oh wait, you're zoomed in really, really far.
Yeah.
But yeah, you see how like it's not a change in sign, therefore it's not an extrema, but you can see the blip on the graph.
So is that perfectly vertical then? No, perfectly horizontal.
It will vary. It's gonna, like, I mean, you can't say every time it's this or that. Like in this case, it became vertical. Sometimes it could be horizontal. It just means that when it doesn't change signs, it's not an extrema. And it's going to be a point where you do see something like Josh suggested, a change in slope. So you can see on your graph, like it goes kind of smooth and then like that one kind of juts off after 0.
So this one is kind of like a point of inflection, right? So if it's
Well, we can determine if it's a point of inflection on the second derivative. See if it changes concavity.
We're gonna find it anyways.
We were. It's not like it's not in the notes anyways.
It says it right
But that's
there.
what I'm saying. Take that idea, take those thoughts, and see if they're true.
It just makes sense.
Hey,
I didn't say anything.
Yes, you did, and I could go back and prove it.
No.
Yes.
This is not delete the file. You have to re-record the lesson all by yourself.
I probably at this point, this is probably the third time I've recorded this lesson because I've been recording for like 3 years now.
Well, then I'll go in your YouTube channel and get you recorded and deleted.
No, just copy striker.
Goodbye all
No,
videos.
copy striker did.
Oh yeah, I'll do that.
All you have to say is that you're
I'll
a
accidentally spell your
independent
college
person
on
working
your
for college board, and then boom, copy strike. That's how YouTube works.
I'll hack your Minecraft account.
I'll see
No,
you.
you
Alright.
won't, Josh.
Let's take our second derivative. You have 2 choices. You could distribute the 4/3. You could keep it out in front. Where do you want to do with it?
Yeah.
If you keep it out in front, it creates a product rule, even though the second part of the product rule is going to automatically be what? 0.
So, product
So-
rules easy.
If it's easier for you to keep it out in front, go ahead. Now you don't have to worry about fractions and your quotient rule.
Yeah, trust me, I just tried the first one.
So out in front, so it's Hody high minus high, column.
Oh, you know what? Yesterday night when I was doing my homework,
Yeah.
I don't think I did any of the.
Is that why they were all wrong, maybe?
That might be why.
Hody high minus high ho, I'll never have hope. And then this would just be like plus 0. So it'd be the first times rid of the second plus second times rid of the first. Rid of the first would be 0. So because this is a fraction.
I know, but I have that.
I mean, yes, you could take that one. That's fine. It's a good
I
thing.
was so tired of being and I just cried and then I went
Okay.
to sleep and now I'm congested and I blocked out. I'm not sick. Wait, he was on the phone with me when I was crying because I was so tired.
You know what trite means?
Trite. It's utter trite. It didn't even send me exactly the same thing. It didn't send two either. So it is. Tripe's also
Stripe
stripe.
Okay.
And this stripe is tripe.
Stripe.
Zebra stripe.
So what'd you get, Josh?
4. I have to calculate it fully, but I have 4 over 9x to 2/3 plus negative 8 over 9x to 5.
What?
What on earth?
Huh?
Did he use his cheating calculator?
No, like I just did it.
Oh, you lost that one. You lost your cheating calculator.
I don't have. Let's go on.
Okay, am I good stopping where you have it? No. And did I have to distribute the squared in the bottom, or could I just have x to the 2/3 on?
It won't matter.
Okay.
Because no matter what, your denominator is always going to have a critical point at, whether you distribute or not.
Hold up. I just need to
Okay.
I'm not
Saying
I
his
just did it by
point of
subtraction.
view is
Oh, wait, why did that become negative?
that doesn't exist.
hold up.
Why is that a negative 2/3?
Wait, what's in the denominator?
Okay, never mind. That makes sense.
Wait, what?
Yeah, did you remember that? Using
Nope, 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 nope.
I want to figure out which one.
He's
Hold on.
still
He's
thinking.
doing the hard way.
That's the easy way.
No, because you just do subtraction.
Can you?
He took the
Alright, so let me
derivative
think
from way
about
back
it.
up here. Yeah.
It's so easy. Look, it's one step.
Josh!
I'm trying to learn.
Okay, but what?
I'm learning.
I know. We'll show them in a minute. It's okay.
Wait, is there an easier way to do this?
He took the derivative from way up here.
Yeah, that was
But
part
then
I
if-
started with that.
Yeah.
Because I hate fractions.
He gets the same thing.
It's also not fun. Like I started with that, and
It's
I
one
just
line.
ended up.
One.
Yeah, but I can't multiply fractions. I don't trust myself. Because I
That's a
suck at
4.
multiplying
Okay.
fractions.
And from over here, it just looks like a
I can't
Just
multiply.
yeah.
I can't.
Okay,
multiply
find
by
your critical
negative.
points. Find your critical points. So what do you automatically know is a critical point?
0.
I can't multiply fractions. I know how to multiply fractions. I don't trust myself how to do it. You need to be humble.
Okay, how about your numerator? What's going to make this numerator equal to 0?
Josh,
This is
what?
How do you get, what's
0.
going to set the numerator equal to 0?
0. 0.
Not a number one? So like the denominator is easy. You know the denominator is easy.
Yeah.
Did you find critical points? What critical points did you find?
It's 0.
Okay.
There is a 0. I think she means there's no one.
I want to make sure you like check that there's not another one. Like how would you go about solving that algebraically?
You just set it equal to 0.
Okay.
That's 0.
Because one won't work. That's the only other number you could look at. I just wanted to make sure he did it his way too. Because he has fractions and negatives and.
Oh yeah.
Okay. What's happening on the left side of 0? Like -1.
Yeah, I'm going to negative 1.
So negative numbers squared is always. Okay, so it's 1/3. A negative number under a cube root will become, so that becomes positive. So 1/3 plus 2/3 is positive.
Eat it. Let's eat it.
Okay,
Why do we have to do this for this one too?
because you're checking for concavity. So you want to know, is it concave up, concave down, and it has to go from concave up to concave down for 0 to be the POI that you suggested.
So what would it have to be? Negative on the other side?
So if you plug in a positive 1 here, you get 1/3. Plug in a positive 1 here, you get,
Negative. Eat it. Told you.
therefore 0 is a POI.
Told you.
So, in terms of what all of this means, it means it's decreasing from negative infinity to -1, increasing from 1 to infinity. We have a relative min, no relative max. We have a POI at 0, concave up, concave down. So, again, increasing from -1 to infinity, decreasing negative infinity to -1, a rel min at x equals -1, concave up from negative infinity to 0, concave down from 0 to infinity, and a POI at x equals 0.
Does this sound really spiteful?
Sure.
And I don't mean it that way. What's the point of this? Like, what am I ever going to use this for? Like, what is, like, realistically, what am I going to use this for?
Well, the next unit we go into is optimization.
Outside of school.
Okay, but the next, well, that's what I said. The next unit we go into is optimization.
Okay.
So optimization is probably one of the most applicable uses that, like, you can see of calculus in the real world. So, like, for example, if this were like a canned good and you were going to the store to buy it, they use optimization to figure out what's the most amount of materials you can put inside using the least amount of materials to make it. So we are going to flow away from just functions into like volume of spheres, circles, cubes, etc., trying to optimize their volumes so that like we can make other resources more useful. So like Pepsi cans, cereal boxes, that's why they're constantly like changing shapes, Because somebody's figuring out what's the least amount of material they can use to box those products. So that's what this goes into. But you have to know how to find the extrema. You have to understand what this number line means in order to do optimization. So, fair question.
I'm getting another number 2. X equals 2. So it's a lot. I'll show you this.
From the numerator?
Yeah. I have 4x to the 3 over 3 minus 8. And I get 0 as well.
Yeah, because 0 came from the denominator.
Yeah.
So that would drop down. This would need a 1/3, which would make that 1.
Do you just need 1 pretty much to prove it?
No, you need this.
Oh, so 0.
That's why I asked, like, when we were looking, I was like, are you sure there's not another one? Because I thought you had your graphs out. Does it change signs, though? It may not change signs. So plug in 3. Gross.
No, it doesn't. It increases.
No, I mean, it has to stay negative. So 3 squared is 9. Cube root of 9. Doesn't matter. It's still going to be positive.
Oh, okay.
Don't do 9. Do...
No, it does change that. Because 4x minus 8. Yeah, it's good.
You can do 9, so there's 81, cube root 81 is 3.
That's what I was saying. Like, don't pick 9 because it's going to be gross. Or 3. Pick like a number that's going to work out for both.
You can make 9 then.
You 8.
So you use 0.
Because down, or pick...
Yeah, it should.
Go from here. Go from here. Go from the x minus 2. Where the 3's in your denominator. So it's 1/3. I'm running out of so much board space.
Anything about
That's how we're going to do.
1/3 x to the 1/3.
You don't need for scratch.
Yeah, I haven't left my slide. X minus 2. X minus 2, x minus 2. 3x to the
Okay, on the
1/3.
graph it keeps going up.
Yeah, so if you plug in 3, 3 minus 2 is 1. 3 in here is positive. It's still positive.
So
It does change. It should change signs.
Good for it.
Oh, okay, well it continues. It just
I'm not talking increase or decrease. I'm talking concavity.
Yeah, it looks like it
So
just
does it go
flattens
from a
out.
frown to a smile?
It looks like it just flattens out, but I guess it might be a really small smile.
Which means this is a lie.
This is all.
No, just to here. This is usually why I have my binder open, so I can always check and not feel claustrophobic. What do you mean you have no idea? Okay, look. I knew I was running out of board space. When you pull out and do, and that's why I tell you to always create your common denominator. Because since this had an x to the negative 1/3, we could easily see 0 was going to create a 0. But what happens is, by not creating the common denominator, we lost the x minus 2. Which up here, if you didn't create your common denominator, you would have lost the x negative 1. Because you had 2 separate fractions, and it's easy to say, oh, 0 works, but what happens is you miss that extra piece. So that's why I say create that common denominator, because then you're not going to miss your extra piece. Sorry, you don't have another example, do you? Not new.
Where you make that right to go on the road.
Alright, a lot of times in here, we do a problem, and a problem randomly say to you, a particle in motion. And then you're like, nope, done, out. So that same idea can be applied to these types of problems. So it says a particle moving along the x-axis with the position function given for x of t, find velocity and acceleration, describe the motion of the particle. So again, everything we did can be used to describe motion. You can take that same idea of increasing and decreasing and now put it towards direction of movement. So instead of saying it's increasing, it would be moving to the, instead of decreasing, it's moving to the flat. Instead of concave up, we're talking about acceleration. So if it would be concave up, it would be accelerating. If it's concave down, it's decelerating. Okay, so let's find velocity.
The whole span of things we could have about 100% accurate, so much
Mr. Reed.
So you have 6t squared minus 22t plus 22. In order to find my critical points, I would factor out a 2. That is factorable.
Wait, what? How do you do that? Wait, how do you just, oh, yeah, okay.
How do you do this so quick? Oh, no, her favorite. Cheating.
To find it out.
Hey, you gotta do what you gotta do.
Honestly, if I had to do that the long way, I'd do my tic-tac-toe method.
I've always just kind of guessed.
Tic-tac-toe.
Like, you make a tic-tac-toe board and you figure out the factors when there's a value.
Oh, I know what
Right.
you're talking about.
Or you can do reverse FOIL.
I have no clue what you're talking
Yeah, you show us the
I just know what tic-tac-toe board was.
about.
Oh,
I've always just sat here and thought about it. I figured